Hello, and we are Team Nimbus, and we are going to do our presentation on social media analysis of tweets on a cloud-based distributed environment. I'm Vikas, and we are a team of 3 people total with Monosija Mehti and Karul Chatterjee. So, in this project, we have tried to overcome a very crucial problem of using Twitter API. So basically, Twitter API provides us a way to get the live tweets being tweeted by users through a streaming API where you connect to the Twitter servers and you tell the Twitter saying that okay, give me these tweets if they match one of these keywords or location or user profile. But the problem here is Twitter only allows one stream at a time from one IP address. So in order to overcome this problem, we came up with the solution of having a distributed network of a set of slave servers with identical streaming servers where each can be connected to Twitter and the data can be collected parallelly from each slave server for different set of keywords. Along with that, we are using a regime based indexing data store, that is Elasticsearch, with a master and the slave node to provide us with very fast data indexing and search features. And besides that, once the data is received from Twitter and stored to Elasticsearch, we use D3 charts and Google Charts to show the dashboard with the analytics. Now I'll go ahead and talk about the different things used on the project. One of them being the supervisor, that is the package which we are using in order to demonize the tweet collection process. And then we have Elasticsearch, we have T3 visualizations, we have Google Charts and Nginx web server that serves our web pages. And we are using 6 virtual machines, where one virtual machine, the first one is the dashboards, analytics dashboard, and the second one is the Elasticsearch master, and the third one is Elasticsearch slave, and the rest 3 are data collection nodes. Here you can see the project architecture of the project we are working on. Here we have, starting from the right side, you can see 3 slave servers whose main task is to connect to streaming API on Twitter and then receive tweets as and when required. They all get their tweets and they push their tweets to Elasticsearch. From the Elasticsearch, the tweets can be viewed on the analytics dashboard. The analytics dashboard is served via the web server, and it has a connection to Postgres server in order to save and fetch the project data. Now this is the DFD where we show how the data flow happens on the code platform. So considering the Twitter API on the top from where the data origins, it goes on to the 2 different data collection nodes depending on how many parallel projects you have running. So once the data collection node receives the data, it pushes on to Elasticsearch master, and Elasticsearch master node synchronizes a replica of the data onto the Elasticsearch slave, since we have defined to maintain one replica of the data for parallel storage, so that if one of the node goes down, then the other node can be used for data retrieval. And from Elasticsearch master, the data flows onto the data analytics dashboard where the data is visualized. Now, yes.
Hello everyone, I'm Monosija, and we'll discuss how we have divided our work to accomplish this project. First, we have decided to set up the servers required, and we have decided to complete all the installations and connect the distributed systems. Then we wanted to develop all the background processes, and at the end we wanted to complete the web-based analytics dashboard. So our midterm goals were mainly to set up the system virtual machine, to get the database started up, set up, get the Elasticsearch set up, and all the daemon processes we wanted to make it work. Then for the final goals, we had our main aim was to actually collect the maximum amount of tweets and develop an analytics dashboard and then deploy it to server and run it perfectly. So this is what we have done. So task accomplished in phase 1 is we have defined the problem statement, we have defined the project scope, and we designed the product architecture to solve this problem. Till midterm, we set up the virtual machine, and we did the database service setup, and we also completed Elasticsearch setup and the daemon processes. In the final, we collected all the tweets, we analyzed the tweets, and we have created various charts to show an analytics of all the tweets collected. Our code repository is mentioned here, and also an analytics public dashboard. The public link for that is mentioned here in this slide. Well, the main risks and benefits that we faced. The risks is that the main benefit of this project is this will be a single application which will help us analyze the overall contextual polarity or the public opinion based on different social issues and trending topics, and we would also be able to do location-based tracking and track any antisocial activities. However, the risks and challenges that we might face are Twitter might block us as users because we would be fetching critical information. There could be some problems hosting application in the cloud environment, and also running the tweet data on multiple servers could be an issue for us. So we have tried to issue as much of these problems and solve them.
Yeah, hi. So I'm Kalul. I'm going to tell you about the application and the screenshot given in the slides. I will going to run the application also, the analytics dashboard. So as you can see, this is the screenshot of the Elasticsearch project index. So you can say index as a normal database table which has different shards running on it, and the number of docs is the number of elements that this index have. And so the way this Elasticsearch works is it have a master and slave node which is connected to some different nodes which have their own database schema for it, and this all things are collected in a Twitter master which will be used in the analytics dashboard one. This is showing the cluster health of this thing. The project architecture is already described by my teammate. Now I'm going into the details of this. This is the daemon process that we run to get the data from Twitter. This is a Python based process. So this is the screenshot of this application that we are going to run. We will open it in a browser and we'll show it to you. So as you can see, this is our analytics dashboard. We did a different kind of analysis on the data collected from Twitter. We did the sentiment analysis that is based on this sentiment analysis is done on an algorithm based on pattern analyzer on Python library, and there are different kinds of we did some other analysis like this trending hashtag. So what we did is we used a set of keywords for movement that is going on in South Africa for the education right and the increasing educational cost. So for that we use this thing, we did the sentiment analysis, the trending hashtag is there. Then we use the user mention, that like in any tweet we can use some we can mention some user. So those things are which are the top 10 users that are mentioned here. The daily tweet distribution will show the number of tweets that was posted on a daily basis. So for some of our development activities this period we don't have any tweets because we are still working on the script, and then again it started working. Then this shows the top 10 users who are the most number of users who are tweeting on these topics. Then these are the trending words. So all the tweeters who are using tweets for this set of keywords, what are the words that they are using mainly? So this is a word cloud for that. Then we used a geographical analysis on from which part of the world these tweets are coming from, and also we are showing the current tweets, the viral tweets of according to this time range. So if you can click it, you can go to Twitter also, and if you want to do something like or you retweet, you can do that. So these are the analysis that we have done on this analytics dashboard. Now let me go back to the PPT. So here I have already shown you this in the application. Yeah, so we have also used, we have totally used the cloud feature in our application. So we have incorporated all the cloud features in our application, like on-demand self-services, broad network access, resource pooling, rapid elasticity, and immediate services. These details are there in this PPT, so you can definitely get it from here. And the part of the future work that I must say, which is a very important thing, because this is a one semester project, so we have planned accordingly and we have finished all the things that we want to do, but there are some, obviously there is some chance of modification to it, which will definitely make it better and better. So the first thing that I need to mention, that this is a social media data analysis tool, so if we can add more data from Facebook and Instagram and other social media, that would be a really nice add-on to this. Then if we can add some historical data, because now this tool is getting data from the day we start running the script. So if we are able to get the historical data from Twitter and more social media data, so it would do some more analysis. And the script that are we running, we have to run it manually. So if there is an automation and proper user interface for that, that will be a very good add-on for this project. So by saying this is our future work, and we have already explained our project. I want to conclude this, that we have really put some hard effort on this, and thank you for it.